Packages are a way to store reusable code throughout a model. Instead of declaring the same construct to use in each separate VHDL file, I can simply place the information in a package, source the package, and save myself some typing. The package consists of a package declaration and a package body. The package declaration is required and is used to declare identifiers that you will be using, such as type declarations and subprogram declarations. The package body is an optional section. Though you can declare items in the body, it is typically used to define the functionality of subprograms that were declared in the package declaration section. VHDL has two built-in packages called the Standard and Text.io packages. The Standard package defines built-in VHDL data types that can be used for designing and associated operators that go along with them. The Text.io package provides support for file operations, for example, reading and writing to external data files. Here is an example of a package. The package starts with the keyword package, the name of the package, which is filt_cmp is, and then the package declaration section. In this package declaration, I have two things being declared, a type called state type and a function called compare. This function takes in two integer variables and returns a Boolean result. I end the package with the end package filt_cmp. Since I have a function being declared in my package declaration section, then I'm going to have a package body in which I'll define the functionality of that function. So it starts with the keywords package body, the name of the package is, and then the definition for the function compare. The package body is ended with the keywords end package body and then the name of the package. Libraries contain a package or collection of packages. They are essentially directories where your packages are located. Using a library, I can assign a unique name to a directory path where my packages are compiled. Then, by sourcing the library by name, the tool knows where to go look for the packages that my design calls out. Libraries can come from various places. VHDL has a standard library that contains the standard packages I referred to in the last slide. IEEE came along and created additional libraries that are supported by almost all VHDL compilers. Specific silicon vendors like Altera created further libraries from which you can call vendor-specific information. And you can also create your own libraries in which you store your own units for reuse. The current project library in which you are designing is called the working library. If you don't indicate that you want something compiled into a specific alternate library, then it will automatically be compiled into your working library or directory. Before you can use any package, it must be compiled into a library. If you don't compile it into a particular library name, then it will automatically be compiled into the working library named work. To use a package, you must first call out its library using the library clause. Again, the library name is a symbolic name that refers to a directory containing your compiled packages. Each VHDL compiler you use will have a specified way to associate a name to a particular directory path. To call out a library, you type the keyword library followed by the library name. After that, you use the use clause to call out the package within the library. Both the library work and standard std are considered implicit libraries and do not need to be explicitly called out by your design. Here is an example of the library and use clauses. In this example, I am calling out the IEEE library since it is not an implicit library. If I had multiple libraries that I wanted to use, I could simply list them separated by commas. For the use clause, I type the library name dot the package name dot the object in the package I want to reference. If I want the entire package available to the model, then I can use the keyword all, which you will find most designers do since it is simply easier and the memory impact on your system is negligible. The library and use clauses are placed at the very beginning of your model so that they can be accessed by all of the design units in the model. The standard library is the default library in VHDL. It contains two packages, the standard and the text.io packages. The standard package defines the default VHDL data types such as bit, Boolean, integer, real, and time, and operators to support these data types. The text.io package supports file operations. Since the standard library is built into VHDL, it does not explicitly need to be referenced by your VHDL model. Here are some data types that are defined in the standard package. First is the bit data type. It defines a two logic value system made up of 0 and 1. Thus, in the first example, I can see that a temp is being declared of type bit, so it can hold either value 0 or value 1. If I want to make an array of bits, then I append underscore vector to the data type. So in the second example, I can create a signal called temp that is a bit vector. When I use vector, I need to indicate the width of the vector. There are essentially two ways to do this. You can say 3 down to 0, indicating that the MSB is on the left-hand side, or 0 to 3, indicating that the MSB is on the right-hand side. Both will create a 4-bit vector. Most commonly, you'll see the down to being used. The next data type is type Boolean, which defines a value of false and true. And the third data type on this page is integer. The integer data type defines a decimal value, either positive or negative. If you just declare a signal to be of type integer, then in memory it is stored as a 32-bit number. That's the highest number it can create, even though in VHDL it is truly just a number, a decimal number. If you want to limit the value or what your integer can be, then you can use the range keyword. So in the last example, you can see that this integer int temp1 has been restricted to a range of 0 to 255. Though in memory it's an 8-bit number, that's how it's stored, it's actually just a number. It's just a single value, and the highest value can be 255, the lowest value it can be is 0. Here are some other data types defined in the standard package. There's type natural, which is an integer with a range 0 to the highest integer supported. There's type positive, which is an integer with the range from 1 to the highest integer. Type character is the list of all ASCII characters. Type string is an array of characters. And then type time allows you to specify time units, so it always includes a value along with a unit of time, such as picoseconds, milliseconds, seconds, and even hours. In order to model hardware even better, IEEE developed additional packages that can be used. These are defined in the IEEE library. The packages are Standard Logic 1164, which defines a brand new data type called Standard Logic and functions to go along with it. Standard Logic Arith, that defines arithmetic functions that can be used on Standard Logic. And then Standard Logic Signed and Standard Logic Unsigned, which define further arithmetic functions depending on if your notation is signed or unsigned. The standard logic data type defines a 9-logic value system made up of U, X, 0, 1, Z, W, L, H, and dash. These provide a much more complete picture of the hardware system you might be developing. Looking at these values, 1 represents a logic high, 0 represents a logic low, X stands for unknown, Z we use to bake tri-states, dash is don't care, U is undefined, and then there are the weak values. H is a weak logic high, L a weak logic low, W is a weak unknown. The way standard logic works is that if you have a signal that has multiple drivers, then the standard logic value system always is a resolved type. So for example, if I have one driver that is driving a 1 and another that is driving a Z for tri-state, then the result value of that signal will be a 1. If I have one driver that is driving a 1 and another driver that is driving a 0, then the result value of that bus would be X for unknown. The 1164 package also defines a data type called standard U logic. This uses the same 9 values as the standard logic, but it does not support multiple drivers. So if two signals try to drive two different values, or two drivers try to drive two different values on the same signal, then an error will occur. So that ends our first section. In this section, we discuss some terms such as synthesis, behavioral modeling, and structural modeling. We talked about the 4 design units in VHDL: the entity, the architecture, the configuration, and the package. And we finally talked about libraries and how packages are collected into libraries. Specifically, your working library, there's a standard library, and then the IEEE library.